application of anybody else. She told that nodal analysis is the application of Kirchhoff's current law, right? Not actually true, but there is some other parameters also. Who can tell me? Anybody else? My question is specific. What is the difference between Kirchhoff's current law and nodal analysis? She told that nodal analysis is the application of Kirchhoff's current law, KCL, right? Though it is partially true, but not totally correct. You no doubt it is the application of KCL. Nodal analysis is the application of KCL. But what is the actual difference between nodal analysis and KCL? Yes, KCL, nodal analysis is nothing but KCL plus Ohm's law, right? If you introduce Ohm's law with KCL, Kirchhoff's current law, that will become what? Nodal analysis. Similarly, if you introduce Ohm's law with Kirchhoff's voltage law, KVL, that will become mesh analysis, right? So I think you must have idea about it. What is the difference between nodal analysis and KCL and nodal mesh analysis and KVL, right? Mesh analysis is nothing but KVL plus Ohm's law, right? KVL plus Ohm's law is the mesh analysis. KCL plus Ohm's law is the nodal analysis, right? So now basically I am here to I'm going to provide you two numerical. So you have to solve these two numericals. These are going to be basic numericals, right? Not advanced level, basic level numericals. Since you are now at learning stage, so that's why I'm going to provide you only two basic numericals, not advanced level. So you have to solve it by using both nodal analysis, first by nodal analysis, second by mesh analysis. Is that clear? And by both of the ways, we are going to get the same answer. You must get the same answer, right? By using nodal analysis as well as mesh analysis, you have to get the same answer. Am I right? Right? So now, draw the first numerical. Question number 1. Okay. So write down question number 1. The question number 1 is, so draw the circuit diagram first. The circuit diagram is going to be so here is another resistance. Here is another resistance, and all the resistances are having values 1 ohm each, right? Here is the voltage source, having 10 volt, and here is a current source having value as 2 ampere, right? And here is another branch which is having a resistance. Let's say it is 1 ohm and it is 2 ohm, right? This one is having value as 10 volt. Is it visible to everyone? Right? These resistances are having value 1 ohm, 1 ohm, 1 ohm. This one is 1 ohm, and this one is a DC voltage source, 10 volt, having value 10 volt. This is a current source having value 2 ampere, and here is another branch joining these two nodes, and the resistance value of this branch is 2 ohm. The question is determine the value of voltage across this 2 ohm. The question is determine the, write down the question. The question is determine the value of voltage. Determine the value of voltage across 2 ohm. Let it be B, right? So determine the value of voltage across 2 ohm by using nodal and mesh analysis. By using nodal and mesh analysis. Can you solve it? Okay, try to solve. This one is basic. Sir? Okay. Yes. Okay. So those who are already done with question number 1, they can go for question 2. See, question number 2 is nothing but a small modification. Question number 2 is going to be the small modification in question number 1. Yes. Right? So the small modification is going to be like this. So the current source will be shifted here. And the voltage source will be there as it is. And here will be one resistance. Right? So this one is 10 volt. This one is 2 ampere. 1 ohm. 1 ohm. This one is 1 ohm. And this one is 2 ohm. Find out the current flowing through this 2 ohm by using mesh and nodal.
We want to see the first 5 students, those will complete.
Shall I solve it? So starting from question number 1. So first I will solve it. Mesh. Right? These are the mesh. Not loop. What is loop? What is the difference in loop and mesh? Remember, a mesh does not have any loop within it. Node 1. By applying nodal analysis on node 1, tell me what will be the voltage value? Why we are using nodal analysis? Why we are using nodal analysis? Just to find out the voltage of at each and every nodes, right? So you see, just by seeing here, I can easily say the value of V1 is 10 volt. Why? This one is reference node, so this one is V1. So only 10 volt voltage source has been connected here. So what will be the value of V1? It is 10 volt, right? So from node 1, the value of V1 is 10 volt. Hello, sir. Okay. Now come to node 2. Come to node 2. Tell me what is the nodal equations at node 2. Whenever you are considering a node, hey, listen everybody, whenever you are considering a node, we have to assume that the potential at that node is higher than the other nodes. And we know that the current always flows from higher potential to lower potential. Suppose I am considering these nodes, means I have to assume that the potential of this node is more than V1 as well as V3. So that means the current direction is going to be in this direction as well as in this direction and in this direction. Right? So tell me what will be the nodal equations at node V2? It is going to be how much? Yes, V2 minus V1 by 1, then plus V2 by 1 plus V2 minus by 1 equal to 0. Right? So what is the net equation here? 3V2 minus V1 minus V3 is equal to, right? B2 plus B2 plus V2, 3V2 minus V1 minus V3 is equal to 0. So this is going to be the equation number 1. Sorry, equation number 2. So this one is equation number 1, equation number 2. Right? Right? Now come to node 3. So whenever you are assuming a node, so whenever considering a node, you have to assume that the potential of this node is more than other nodes. Right? You have to assume that the potential at this node is more than other nodes. That means the current will flow from that particular node to other nodes, right? So that means here the current direction is going to be in this direction as well as in this direction, and also this in this direction. Okay. So at node 3, what will be the nodal equations? Okay. At node 3, what is the nodal equations? Tell me. So B3 minus B2 divided by, very good, plus B3 minus B1, very good, B3 minus B1 by 2 plus, yes, minus 2, right? Because this current direction is towards B3, right? And our assumed direction is toward this one. So that means here, okay, you see, what is the equation here? It is going to be, wait, so 2 into V3 minus V2 by 2 plus V3 minus V1 by 3 is equal to 2. Can I write like this? Like Karbi? Just 2 I have multiplied here in numerator and denominator as well. Okay. So tell me what is the equation here? It is going to be 2V3 plus V3 is how much? 3V3 minus 2V2 minus is equal to, very good, 4, right? So this one is going to be equation number, am I right? Am I right? ठीक है जी? Are yes or no? Anybody having any doubt here? Anybody having any doubt here? Please raise your hand if anybody having any doubt. Correct? Right? So we are having 3 nodes. So we are getting 3 equations. So now you can easily get the variables V1, V2 and V3. Okay? So you see V1 is already known to us, that is 10 volt. V1 is already known to us, that is 10 volt. And you have to find out the value of V3 now. V2 and V3 both. Okay. So tell me how to find out the value of V2 and V3. 70 minus 62 by 7 is equal to 8 by 7. Yes, we are getting the same answer, right? We are getting the same answer. 8 by 7, no? Yes, you see, in the nodal analysis, we have get the same answer, 8 by 7 volt. Now through the, in the mesh analysis, now by using the nodal analysis, we are getting the answer as, yes, it is V1 minus V3. So B2 ohm is equal to V1 minus V3, 10 minus 62 by 7, 70 minus, yes, 8 by 7 volt. Yes. Getting? So you will get the same answer. By using nodal analysis, you have to get the same answer. So that's why you have to verify. That's why you have to verify whether you are getting the same answer or not by using nodal analysis and mesh as per your convenience. Okay, so easy kuda lagala, mesh or nodal analysis? Mesh or nodal analysis? Yes. Yes, nodal is comparatively easier than mesh. But remember, if a circuit contains more number of current sources, it is advisable to use mesh analysis. If a circuit contains more number of voltage sources, then it is wise decision to use nodal analysis. Do remember this.
Everybody, initial power. have a teacher, so we will finish.
You finished it? Question number 2. Anybody who have completed question number 2? Anybody who have completed question number 2? No one? Okay, so what is the question number 2? The question number 2 is asking, find out the current flowing through the 2 ohm resistance, right? Again, we have to solve this. Again, you have to solve this by using both mesh as well as nodal analysis, right? So can you solve it by yourself? Can you solve it by yourself? So first, use mesh analysis and find out the answer. First, use mesh analysis and find out the answer. See, how many meshes are here? How many meshes are here? 3 meshes are here, right? So this one is one mesh, mesh 1, mesh 2, and here is mesh 3, right? Total 3 meshes. Yes or no? Total 3 meshes are here. So how many equations can be formed? Obviously, total 3 equations can be formed. But here you see, in this 2 ampere, is the voltage across this 2 ampere is known to us? Is the voltage across this 2 ampere is known? No. So that's why through the 2 ampere current source, we can't apply the KVL, right? Rather, we will take this whole loop as well, right? You have to take this whole loop and use the KVL and find out the KVL equations. Is that clear? Right? So now tell me.
Sir is talking about the super mesh.
Yes.
Super mesh means instead of using a small mesh, sir is talking about a bigger mesh.
Yes. You see, this loop is known as a super mesh, right? This is known as a super mesh. This is known as individual meshes 1 and 2, and this total mesh is known as super mesh, right? Because through this current source, we can't apply KVL. So that's why we have skipped it, and by using these 2 meshes, we have formed a super mesh. This is known as super mesh. So in this super mesh, we have to put the KVL and find out the equation, right? Tell me what is the equation here, starting from here, minus 10, right? Then I'm talking about the super mesh, right? So by applying KVL, in mesh 1 and 2, combined known as super mesh, right? Tell me, what is the first element? It will be starting from here, minus to plus, minus 10. Then what is the voltage drop across here? This one is clockwise, right? I1, and here it is I3 anti-clockwise. So net current will be I1 minus I3 into 1. So it is going to be I1 minus I3 into 1. Then I'm coming here. Tell me, what is the equation here? This one is I2 and this one is I3. No, this one is I2 na. I2 is flowing clockwise and I3 is anti-clockwise. So what is the net current? Through this 1 ohm, it is I2 minus I3. I2 minus I3 into 1 ohm. And then plus it is I2 na. So it is very good, 2I2. Any other element here? No. Tell me, what is the net equation? What is the net equation here? So I1 plus 3I2 then minus 2I3 is equal to, very good. So this is going to be the first mesh equation. Everybody getting this? Or anybody having any doubt here? Anybody having any doubt here? Please ask. Okay, everybody getting this equation? Getting this equation, right? So first equation is going to be I1 plus 3I2 minus 2I3 is equal to 10, right? And then you see, I'm going to equation number 3. You see, another equation is also can be formed here. Another equations can also be formed here. What is that equation? This 2 ampere. This 2 ampere, right? You see, this 2 ampere is downward or upward? Upward. You see, that means net current is going to be upward direction. So tell me, which current is upward here? I2 is upward and I1 is downward. Net direction is upward. So that means I2 is going to be plus, I1 is going to be minus. So net current is going to be here as what? Very good. I2 minus I1 is equal to 2 ampere, right? So this is the equation number 2. So by using mesh 1 and mesh 2, we are going to get two equations. First one is by using super mesh. Second one is the supporting equation. This is nothing but the current difference of the two meshes. Is that clear? Now going to mesh 3. Tell me, what will be the mesh 3 equation? What will be the mesh 3? So by using KVL, in mesh 3, tell me what will be the equation? Mesh 3 means this one, no? Right? So the first one is, this one in the direction I3, this one is I1. So I3 minus I1 into 1. And then this one is 1 into I3, right? Plus this one is I3, this one is I2. So I3 minus I2 into 1, right? Am I right? So this is going to be 3I3 minus I1 minus I2 is equal to 0, right? 3 variables, 3 equations, right? 3 variables I1, I2, I3, and we are getting 3 equations. So can you solve these 3 equations and getting the value of I1, I2, I3? Tell me. Solve these 3 equations. This one is equation number 1, 2, and this one is equation 3. Tell me, what is the value you are getting for I1, I2 and I3? The question is asking, find out the current flowing through this 2 ohm, right? Flowing through this 2 ohm. And what is the current flowing through the 2 ohm? It is? What is the current flowing through this 2 ohm? It is? Very good, I2, right? So if anyhow you find the value of I2, the question will be solved. Yes? Very good, 4 ampere. Anybody else getting the answer? I2 was 4 ampere. Solve these 3 equations. Solve these 3 equations and find out the value of I2. See, what is our objective? Our objective is to find out the current flowing through this 2 ohm, right? Flowing through this 2 ohm resistance. And what is the current flowing here? You see in the mesh 2, I2 is flowing, right? I2 is flowing. So if anyhow you find the value of I2, your answer will be, question will be solved, right? So the I2 answer, by solving these 3 equations, we are going to get I2 as 4 ampere.